Hello, and welcome to our tutorial video demonstrating the integration of BioPac MP160 with BCI 2000. In this video, we will discuss the necessary steps to connect your BioPac amplifier to BCI 2000. BCI 2000 is an open-source, multi-purpose software tool for real-time biosignal acquisition, processing, and feedback. BCI 2000 is very adaptable and can accommodate a wide range of neurophysiological experiments, including simple stimulus presentation tasks, neurofeedback tasks, and interface experiments. Additionally, it is very easy to add peripherals, such as the Xsense motion trackers. The BioPac MP160 is a flexible, 16-channel system that provides modular data acquisition for life science research. Applicable to over 40 research fields, new modules are available for electrogastrogram, electromyogram, electrodermal activity measurement, respiration measurement, and others. The MP160 system connects to the research computer through an Ethernet cable and supports a wide range of wireless and wired signal-specific amplifiers. The MP160 is implemented as both a BCI 2000 source module and as a logger. As a source module, the MP160 is treated as the time base for data acquisition. This means that any peripheral devices will be sampled with respect to the MP160. You should implement the MP160 as a BCI 2000 source module if this is your primary electrophysiological signal acquisition device. As a logger, the MP160 is implemented alongside a primary electrophysiological amplifier. This means data acquired from the MP160 is resampled to the primary source device. You should implement the MP160 as a logger if you are using it to acquire additional biometric information, such as skin conductance or respiration, but want to use another device for your primary electrophysiological amplifier. In this video, we will discuss implementing the MP160 as a BCI 2000 logger. For more information, please refer to the BCI 2000 wiki pages for source modules and loggers. In this tutorial, we will implement the MP160, be an RSPEC, be an EGG2, be an EMG2, and be an PPG-ED into BCI 2000, which will allow us to acquire the respiration signal, electrogastrogram, electromyogram, and electrodermal signal. First, it is important to verify that you have all the necessary hardware for MP160 and a capable BCI 2000 PC. Make sure that you have the MP160 and a wireless amplifier, the power supply for the MP160, an Ethernet USB adapter, and an Ethernet cable that you can connect to your MP160 with the BCI 2000 PC. You will also need the Windows PC that will be running BCI 2000. You can find the BCI 2000 installation tutorial on the BCI 2000 wiki pages. The hardware connection is simple. Using the Ethernet cable, plug one end into the MP160 and the other end into the Ethernet USB adapter. Then, connect the adapter to the BCI 2000 PC. Alternatively, if your PC has an Ethernet port, then you could directly connect the PC with the MP160 using an Ethernet cable. Now that we have finished the hardware setup, we are ready to set up the batch file, which is used to start BCI 2000 on the BCI 2000 PC. Navigate to the BCI 2000 directory. In the batch folder, open the BioPac logger.bat and append BioPac logger equals 1 next to the signal source module. In this case, we are using signal generator, which could generate a test signal suited for BCI purposes. For the signal processing and application modules, we are using dummies for demonstration purposes. Run the batch file to start BCI 2000. Press Config and navigate to the Source tab. Scroll down until you see the BioPac logger section. BioPac channels is the number of connected channels of the MP160. This number must exactly match the number of wireless transmitters you are planning to connect to the MP160. BioPac block size is the number of samples acquired from the MP160 at a time. The recommended range is 100 milliseconds to 8 seconds. BioPac sampling rate is the sampling rate of the MP160. The maximum sampling rate is 1000 Hz in the logger module. Lastly, BioPac channel matrix is the information of the connected channels. You need to specify the channel ID and corresponding signal types in this matrix. For example, in our case we connect RSP, EGG, EMG, and EDA amplifiers to the MP160. Corresponding channel IDs are 1, 2, 3, and 12, so the BioPac channel matrix should be filled with 1, 2, 3, 12, and on the next row, RSP, EGG, EMG, and EDA. To view the MP160 data that BCI 2000 is collecting, go to View and then States and Events to see the available MP160 states. Right-click on an MP160 event and click Watch to see it in real time. The state BioPac_channel X is a signal from channel X. X is a channel ID. Different MP160 amplifiers have different signal ranges. Respiration ranges from -10 to 10 volts. EDA ranges from 0 to 50 microsiemens. EMG and EGG range from -10 to 10 millivolts. These MP160 events will be stored as BCI 2000 events to be used for real-time feedback or evaluated after the experiment is complete. BCI 2000 events can only be stored as unsigned integers. This means the units of the various MP160 signals, voltage or Siemens in the examples above, are not stored. Signals acquired from the BioPac logger are rescaled to 32-bit unsigned integers. To convert back to the original signal scaling, use the following scaling equation. Min is a minimum value of data. Max is the maximum value of data. For example, for the EDA signal, the min is 0 and the max is 50. For respiration, EGG, and EMG signals, the min is -10 and the max is 10. For skin conductance measurements, we need to first calibrate the amplifier before data are acquired. After configuration setup, press Set Config and a dialog will pop up. Then disconnect the leads to the electrodes and press Calibrate. Once the calibration is successful, you can reconnect the patient and record data. You should now have all the information you need to add the BioPac MP160 to your experiment. If you have any questions, please refer to the BCI 2000 wiki page. Thank you for watching our video.